I'm going to talk about the 3 types of reactions in the AP Chem curriculum. The first one is the acid-base reaction. The second one is reduction-oxidation reaction, which we also call redox reaction. And the last one is a precipitation reaction. So the first one, the acid-base reaction. Firstly, how we define these acid and base is according to the Bronsted-Lowry definition of an acid and base. The definition of an acid, according to this, is that it is a proton donor. And for the base, it means that it is a proton acceptor. Here, a proton is referring to the H+ ion itself. So how I remember it is, because if you think about the alphabet, A comes before B and then it goes like A, B. I remember it as the acid giving the proton to the base, so A to B. So we're going to look at this example here. If you look at this, you can see that there is a HCl and there's an H2O, and there, as the products of this reaction, there is a H3O plus and a Cl minus. So what happened here is that we can see that HCl gave its proton to H2O. So H2O became H3O plus and HCl became Cl. In this case, HCl was the one giving the proton. So we call this the acid. And H2O was the one that received the proton, so we're calling this the base. And as the H2O received the proton, it became H3O plus, and we're going to call this the conjugate acid. And HCl became Cl minus by giving away that proton, and we're going to call this the conjugate base. So if you look at this, these two pair up and these two pair up, right? And they only differ. These conjugate base and acid, or conjugate acid and base pairs, differ by 1 proton. And that is the characteristic. Next, we're going to look at reduction and oxidation reaction. So here we're going to talk about the moving of electrons. And I'm also going to write it like this. This is referring to the electrons. So a reduction and oxidation reaction, what you have to memorize for this is Leo the lion says grr. And you have to remember Leo and grr. Leo means loss of electrons equals oxidation. So loss equals oxidation. And grr is gain of electrons equals reduction. So gain equals reduction. So we're going to look at this example straight away. So we're going to first give these elements, or these compounds, the participants of the reaction and the products, their oxidation numbers. Al here is neutral, so it's going to be a 0. Cu2 plus is going to be 2 plus. Al3 plus is going to be 3 plus, and Cu is going to be a 0. I have more explanation about these oxidation numbers in a upcoming video, so make sure to watch that one if you're unsure about how these numbers come up. So if we look at the Al here first, Al, before it reacted, it was a 0, but the oxidation number changed to a 3 plus. And for the Cu, before it was a 2 plus, but it became a 0. So in this case, because it went from 0 to a positive number, it lost electrons, which means, so L, think about Leo, and loss equals oxidation. So the Al, aluminium, has oxidized in this case. And for the Cu, we can see that it actually gained electrons because it went from a positive number to 0. And in this case, a reduction has happened. So aluminium has oxidized and Cu has reducted. And the last one is pretty straightforward, and this one is the most easy out of all of these three, I would say, and it's called the precipitation reaction. So we're just going to look at the example right away. The precipitation reaction is probably pretty self-explanatory. It's basically when a precipitate forms from a reaction. So what's important in this equation is not these at the front, but these symbols that indicate to us the state of matter of these compounds. So we had an aqueous solution plus an aqueous, and we got a solid and an aqueous. Here in this case, the solid is the precipitate. And from this, by a solid popping out from the product side of the equation, we can say that a precipitate has formed, and therefore it is a precipitation reaction.